Assalamualaikum and very good afternoon. My name is Faizah Binti Sayuti. I am from Polytechnic Sultan Azlan Shah. Today I will present the innovation idea of the development portable automatic double-sided UV light exposure machine for printed circuit board prototyping using LED technology. Why we use this topic as an innovation idea? So nowadays, most exposure systems used in educational institutions are exposure system with fluorescent UV lamps or metal halide lamps, which is both systems are expensive, too wide UV radiation, and not suitable for the sizes of the PCB to be placed on the equipment. This will result in a waste of electricity in the exposure system if the PCB is in small size. In addition, the UV exposure system only support a single side of PCB, no timer and buzzer to consider, which cause a lot of rough estimates during PCB exposure. One of the major concerns is the costing of the UV exposure system. So, the aim of this innovation idea is to design and build a portable automatic double-sided UV light exposure machine with low cost which has commercial value. And next, to analyze the effectiveness of portable automatic double-sided UV exposure machine. Okay, we look at the characteristic of the innovation idea. As we can see, this is the figure of the illustration idea. Okay, which is the UV LED machine will design with commercialized aspect, portable and lower cost, suitable for educational purposes. The system consists of housings, UV LED circuit, controller, buzzer, and display unit set. The benchmarking of existing machine is considering use UV fluorescent or metal halide lamps with high cost, high power consumption, and produce a wide UV radiation, which is not suitable for the PCB prototyping size. From the table, we can see the differences between the portable UV LED and UV fluorescent lamp, which is we have 5 characteristics for the light emittance, wavelength characteristic, power usage, weight, and life. Okay? For the first characteristic is light emittance. For portable UV LED, light emitting a narrow range of UV light wavelength but at a higher concentration and energy than UV fluorescent lamp. And for the UV fluorescent lamp, emit a slightly broader range of UV light wavelength but at a lower concentration and energy than UV LED. So for the wavelength characteristic, portable UV LED, it has a single peak of wavelength, and for UV fluorescent lamp, has a multiple peaks of wavelength. For the power usage, portable UV LED is better compared to the UV fluorescent lamp, which is less power. Okay, less power than fluorescent lamp. About 12 volt per DC, and for UV fluorescent lamp require more power, about 110 volt AC. The weight for portable UV light is lighter compared to the fluorescent lamp, and for the lifespan, portable UV LED can spend up to 50,000 hours compared to the UV fluorescent lamp, which is about 10,000 hours of functional use bulb. Which is bulbs are replaced every 2 or 3 months depending on the amount of the use. For portable UV LED, bulbs are not replaced. The operation method of this project innovation idea involve 4 phases. The phase 1 is getting information. Number 2 is design and simulation. Phase number 3 is prototype, and the phase 4 is overall finding and result. For the phase 1, getting information, this phase shall be gather information regarding the existing UV exposure machine in the market or other education institution. For phase number 2, for design and simulation, involve 3 steps. The first step is for technical block driving sketch on technologies of LED UV. Number 2 is drawing the hardware casing using SolidWorks software and drawing LED UV panel circuit using Altium Designer software. For the step number 3 for phase 2 is component design and listing the bill of material. Phase number 3 involves prototype. This phase, on phase 1 and phase 2, the LED UV exposure machine shall be built, tested and reviewed by the industrial advisor and instructor. And the last one is for overall finding and result. This phase shall be evaluated systematically, the result from phase number 3. The impact of the innovation idea covers 3 types. The first one is for professional TVET, number 2 is innovative system, and number 3 for social well-being. The impact of the professional TVET, we have TVET infrastructure, which is this innovation idea expected that the cost of using LED UV machine will also be reduced. The cost of infrastructure facilities provided by TVET educational institution compared to the existing machine. The second impact for professional TVET is commercial market, which is to be commercialized in all technical and vocational institutions, such as for all technical like polytechnic and community college, so for secondary school in electronic or mechatronic field, for skill training center such as IKM, ILP, IKBN and Yamara, and the last one for everyone, which is individual user, which required to make PCB board with low cost equipment. For number 2 impact is innovative system, which is covered for economic and safety. For economic, this innovation idea project is low cost to operate compared to the current use. The LED lights don't fade or weaken over time like traditional bulb. And for the safety purpose, this innovation idea is not excessive high voltage, not excessive heat or high voltage power supplies and shutters needed. It is also can individually set on the upper lights, under lights, or lights up and down exposure at the same time to adapt the various exposure environment. And for number 3 expected innovation idea for the impact is the social well-being, which is cover environmental. For environmental, this innovation idea is no ozone emission, and the exposure times 10 to 15 times faster than fluorescent bulb. As for the conclusion, LED technology generates significant cost, energy, and savings compared with existing technology. The use of this LED UV exposure system is low cost and shows excellent results, especially in helping reduce the cost of infrastructure facilities provided by educational institutions. Okay, that's all for today. Thank you.